when two materials meet and you have these electromagnetic dynamics going on, that's what makes the difference.
Basically, what we're doing right now is cutting the tooling to hold the magnetic ring.
When it comes to precision, the measuring microscope has certainly done the job for us. And with it, we've been able to get the copper rings to the level of precision that is necessary. It's really asking too much to farm this out, so we have to do it in the lab. And if you were to see it on the scope, you'll see there's roundness on one end, a chamfer on the other, precision measurements and weights. And with the CNC, the results are that we can do it or make them consistently. Then we calibrate them with the with this high-end analytical balance scale. Here's one that has met our specifications with the CNC. And what we do is put it on the measuring microscope, and we can take a look at the fine details. In fact, we can measure it at very precise levels, even more so than a micrometer. We're looking for a specific weight within our range or within our specifications, and that's what we're getting with the CNC. If you try to do this manually, it will be a nightmare. Well, these are 6 examples that we recently put together. Just keep in mind that making these requires its own toolings, its own considerations, lots of calculations. A lot easier said than done. Now we're phasing over into the magnetics, and we have to tool that up with a grinder, specifically a Dumor. So this is one of the results. We just did the outside. We haven't done the interior yet, but it allows us to interface the emitter with the magnetics. And if we have it right, it'll just require the right amount of pressing. It requires this tool maker's vise, because you want everything precisely squared, because if it's not squared, it will not press correctly, which is why I'm pretty sure this will work. And there you go. It shows that we got our figures right. It's good compression, no damage. It's a good result.
Everything that we do, we engineer before we accomplish it or even set out to the task. The reason for that is what we're doing here isn't any type of nominal or normal. People think it's easy to make a copper ring. Well, yeah, it is easy to make a copper ring in certain tolerances, but when you throw in the third dimension of density of plus or minus 0.05 of a gram, have a good day with that. We just keep moving forward and keep going with what we need to do, and keep making parts and tooling and keep experimenting with what we have.
That's the latest here at SearlMagnetics. We just finished the copper ring setup. We got all that documented. And now we're moving into the magnetic machining process. And once that is done, we'll work on the Teflon and the neodymium. That's it for now.
And still, the scientists say it's impossible to do. Really? But we're going to show you. They're wrong.